Today we're talking about the development of flight. So it's pretty exciting to consider this development because it's happened 3 different times that we're aware of over evolutionary time. So to start to kind of dial you in here, we're talking about birds, pterosaurs, which you may know as pterodactyls, and bats. The development of flight is beneficial because those organisms can cover large territories, they can cover a lot of ground, and that's useful for searching for food, fleeing from predators, or perhaps protecting their offspring. So what we want to consider here is that, again, flight has developed 3 separate times over evolutionary time, and that development, or those characters, the wings, that facilitate flight, those would be called analogous characters. And so what that means is that we have these 3 different groups of organisms that can fly, again, birds, bats, and pterosaurs, but they don't stem from the same evolutionary branch, I suppose. So they're actually 3 separate groups that are deeply rooted relatives in evolutionary time, but they're not closely related there. So if we can continue on in our discussion here, we'll focus in on the first class that has developed flight, and that's class Reptilia, which is rather unusual. So again, this is in the class Reptilia and the order Pterosauria. So if we can kind of break down that word so that you can remember it a little bit better. Ptero, or ter, the beginning of that word, refers to wings, or one with wings, and saur is lizard. So we have the Pterosauria, the winged lizard group here. So these developed in the late Triassic, and they went extinct in the end of the Cretaceous. These were the first flying vertebrates. How we can distinguish which group is which, so which class we're looking at if we're examining a fossil, is based almost solely on the wing morphology. And so if we can dial in again to the class Reptilia, to be specific here, we have a pterosaur here, and I'll kind of trace the arm so that you can take a look here at the wing morphology. So we start with the humerus, we have the radius and ulna, just like in humans. And then we get to the kind of the carpal area and the hand region. And what I want to draw your attention to is this elongated 4th finger. And so why I'm calling it the 4th finger is because we can kind of count the other fingers, honestly, here on this cast. So here's the first, here's the second, here's the third, and here's our elongated 4th finger that provides the axial support for the wing of the pterodactyl. And so something that we want to remember about the pterodactyl, or the pterosaurs, is that specimens of the pterosaurs are found all over the world. So we know that this development of flight was allowing them to just scatter all over the earth and occupy several ecological niches. The second class that has developed flight is the class Aves, and these are the birds. So you'll be most familiar probably with this class of flyers here. So birds developed in the Upper Jurassic, and obviously they're still around today, so we'd call that the Upper Jurassic to the recent. These are the most successful flyers, and they're both extremely abundant and diverse. One of the key features of this class is the evolution of feathers. So feathers are thought to first be developed for protection from weather. Secondly, they're vital to flight. And something we want to consider about feathers is their origin. So some scientists hypothesize that they developed from scales. So one of the ideas that have helped the development of that hypothesis is that reptile scales are made of keratin, kind of a tough, fibrous material, and feathers are also made of keratin. So it's possible that reptile scales eventually led to the development of feathers. Kind of interesting there, and unusual. Another distinguishing feature of this class Aves, or the birds, is the presence of an enlarged sternum, or your breastplate, you might think of, this big bony covering in the front that has a prominent keel. And what the keel is kind of a projecting big bony plate that provides the kind of the point of origin for big pectoral muscles that'll power the wings, that basically allow that flight to happen. And so that's a distinguishing feature. If you find a specimen that has kind of an enlarged breastplate there, an enlarged sternum with a big prominent bony plate that big muscles can attach to, that would clue you in that that's the class Aves. Additionally, the class Aves, they have sturdy hips, which is thought to be for landing, actually. So if you can think of trying to defy gravity and then you're coming in hot, if you will, from flight, you're going to need a sturdy support structure on that pelvic girdle to support the organism, basically, as they're landing there. Lastly, we want to dial into the wing morphology of the class aves because we're using that to distinguish between the other two classes that have developed flight. So the wing morphology of the birds it's called fused fingers. So basically, the end of the upper arm has been fused together into kind of a sturdy structure basically that would help cut through the air and sort of provide a more aerodynamic structure for the wing. So if we want to look at the morphologies and the characters a little bit more specifically of class aves, we'll take a look at our sparrow specimen here. So what we see here is the fused finger wing morphology. So if I can kind of point out where we're looking here, you'll see clearly that the digits of this organism have been fused together into one little sturdy structure at the end of the wing. So if I can show you here, so we have our humerus here kind of folded up under, and then here's kind of the elbow region. We're going up into the radius and ulna, or the forearm if you will, of this bird, and then the fused fingers are right at the end of his arm here, providing the support structure for the wing. Lastly, just to point out here on an actual specimen, is we can see the prominent sternum, or the sternum and the prominent keel here on this sparrow. So the sternum is just kind of this center support structure of bone right in the center of the bird, and then it extends upward into this big bony plate that's called the keel, providing that point of origin for those big pectoral muscles that will power the wings. When considering the class aves, we want to think about the origin of that group and how flight even began developing from reptiles. And so here we have a great cast of an Archaeopteryx, which is thought to be one of the predecessors, or one of those kind of organisms that are bridging the gap between the reptiles and your flying birds here. And this cast shows the reptile form and the presence of a tail here. But other specimens have been found with an impression of feathers actually surrounding this organism. So there is definitely some evidence that this is kind of an organism that's bridging the gap between reptiles and their flying birds. The third class that has developed flight is the class Mammalia, and the order Chiroptera is actually the specific group of organisms that's developed flight. And so these are your bats, basically. And Chiroptera, if we could break down that word a little bit, chir or chir means handed, and then ter again is wing. So we have a hand wing here, and you'll see why in just a minute when we look at our specimen. So what we want to consider here is that bats developed in the Eocene, which is fairly recent, and then obviously they're still around today. So the Eocene to the recent is the class Mammalia here. So the wing morphology, again, that we're using to distinguish these different classes is that bats exhibit basically elongated fingers. So all 4 fingers are greatly elongated, and they provide kind of a skeletal structure to the wing there, to the soft parts of the wing. And so those 4 fingers are different from the birds because they're not fused together, providing kind of a sturdy, stiff support structure, but they're actually, well, I might say rather flimsy, a little scary there, but they fly very well with these elongated 4 fingers providing the structure for their wing. So if we can look at our specimen here, he's a little bit difficult to distinguish which are the fingers here, but I'll try to point them out here. So if you can imagine, his wings are folded up almost underneath his body here. So what we see here is we have the humerus coming off kind of the axial part of the body, our humerus here, our radius and ulna coming up. So here's his elbow right here. And then the 4 fingers are kind of folded up underneath. So I'm actually going to draw your attention down to the bottom here where we see 4 actual projections here. And so if you can imagine, his wings are folded up here, but we still can see the evidence of those 4 elongated fingers. So through evolutionary time, we've been able to observe 3 different classes that have developed flight. And if you think about them kind of generally, you might notice that, well, they all have wings, and that would be the analogous character that we've identified that provides the same function for the organism, which is obviously to fly around. So, but if we look a little bit more closely and dial in onto the actual wing morphology, we can separate these different flying organisms into their different taxonomical groups. So just to kind of reiterate here, we have the pterosaurs with their elongated 4th finger that's providing support for the wing. With the birds, or the class aves, we have fused fingers that have a very sturdy structure for the wing. And then with our class Mammalia, order Chiroptera here, we have four elongated fingers that are providing support for the wing. So what's really interesting about the development of flight is that we have this one function, which is that the organism is defying gravity and lifting off of the ground and flying, actually, but we have that accomplished through three different morphologies, three different wing morphologies that are very distinct, as we've covered in detail. And so that's something that has developed three separate times over geologic history. That is really amazing to me.